Hello students, Ms. Slyman here with your notes on 7.2, adding and subtracting vectors. So in class we sort of learned this idea that a vector is a quantity that has both direction and magnitude, and often the magnitude stands for the speed. So if we look at this example down here, we've been told that a plane is headed due east at 400 kilometers an hour. So if I'm going to show that with a vector, then I'm going to make a line pointed due east. Wow, that's not really, pretend like that's a straight line. So that's pointed east, and I'm gonna put the 400 above it to show the magnitude. So now it encounters a wind going 60 degrees south of west. Well, west is going back this direction, south of west is going down from there. So the wind is going to look something like this. So here's my wind, and it's going 200 kilometers per hour. To really show that this is 200, I should have made it half the length of the 400. So I'm going to come in and erase some of this to be 400, to be half of the 400. So that's my 200, and that doesn't really look like 200. So let's make it 200. Okay. So here's my velocity of the plane. Here's my velocity of the wind. So if I think about putting these two things together, then if the plane is hitting this wind, I can take this wind and move my vector up, because vectors, it doesn't matter where they are. Of course, that 200 didn't go with it. Let's change that. So I want this and this together. All right, here we go. So vectors, like I was saying, can move anywhere. So I'm going to move this vector right at the end of the airplane's vector. And so now I can see that the result of my airplane's going to go a little bit south. It's not going to be going due east anymore. Now it's going to be going south of east. So my resulting vector, and actually I'm going to use my arrow tool to help me, my resulting vector is going to look like this. So there's my result. I'm not going to be going as fast, and I can see that because the vector is shorter, and I'm not going to be going due east anymore because of the wind. So faster or slower? Definitely going to be going slower. What direction does the plane go because of the result of the wind? It's going to go south of east. And the final vector of the plane, well, that ended up being that arrow that I added in. I'll just highlight it here. Here's my final resulting vector. Now let's look at another example. What if the speed of the wind increased to 400 kilometers per hour? So now let's go back. Now our vectors are going to have equal length. So I'm going to use my vector tool again to help me. So my plane is still going 400 due east. And now I'm going to have a vector going the same length. Let's put in a new vector. So a vector that's going to be the same length. That seems about the same length. And it's going 60 degrees south of east, or sorry, 60 degrees south of west. So that means that this angle inside here is 60 degrees, if we think about that. So if I now want to know the plane's direction and speed, well, the plane is now going way more south than it was before. Not completely south, but definitely a lot more south. So let's add in the resulting vector. I'll make that one blue to separate it. So here's my resulting vector. And if I wanted to, I could go in and use trigonometry to help me figure out how long this is exactly. And I could do that by creating a couple of right triangles. But definitely my plane is going much slower, and it's going far more south than it was before. So it's going more south than east now with that heavy wind. So putting those two vectors together, we were adding vectors, and we saw this in our exploration of vectors. that to add vectors, if we're going to add a plus b, we take the tail of b and add it to the head of a. So if I look at this one, I've got vector a over here. Here's its tail, here's its head, and I put the tail of b on the head of a, and then my result is the answer of the addition. So this new vector here is the answer of the addition a plus b. The other thing I can think of is the parallelogram. Where did my parallelogram go? It was just there, I just saw it. Somehow it got deleted. All right. So my parallelogram, so I've got my a plus b again. That was here. But if I look at my vectors going this way, this is b plus a, because I've got a going, the tail of a going from the head of b. So b plus a ends up being the same vector. So I could have labeled this resulting highlighted vector also as b plus a. So for addition, it doesn't matter. A plus b is the same as b plus a. My a got hidden under here. This was a. So a plus b, b plus a are the same thing. Remember, in my resulting vector though, I have to indicate the direction it's going, so I definitely have my direction added to my vector. All right, so let's add a few. Hopefully you've practiced this already in class some, but let's do a plus b. So I see my vector a over here. It's going 1, 2, 3, 1, 2, 3, 4, that looks like. So I'm going to draw in an a. 3, 4 is up here. So here's vector a. When I finish vector a, I start vector b. Vector b goes over 4, it looks like. 1, 2, 3, 4, yep. So my resulting vector, I'll use a line to help me. Here's my resulting vector a plus b. And we use our arrows on top to show the vectors. I'm going to label all my vectors. That's a, that was b. Now I'm going to do a plus c. I'm going to use my lines to help me. So a over 3 up 4, and then c is going over 1, and then it looks like it goes down also 1, 2, 3, 4. So let's put another vector in for c, over 1, down 4. So my resulting vector, I'll change the color. My resulting vector is a vector that goes to the right 3 and doesn't go up or down. Let's label everything. This bottom one was a plus c, here was c, and here was a. Right, c plus a, well, we know from before that that's going to be the same thing, but let's just prove it. So c, I'm going to start c over here, left 1, down 4, and then a, I go, my c is in the wrong place, let me move it. So c, I'm going to move over to here. And again, it doesn't matter where vectors start. They can start anywhere in space. So then vector a is going to come over 3 up 4. And notice I started from the head of c. That's where I put the tail of a. Okay, and so it's not quite on, sorry about that. And then putting in my result, here's my result. It ends up being the same vector. So c plus a was the same as a plus c. Both of them were a vector that went 3 to the right and didn't go up or down. Okay. Single vector, which is bc plus ca. Well, let's find that. bc is this vector here going from b to c. And then a vector going from c to a is this vector, c to a. So my resulting vector BC plus CA, the resulting vector, is this one here. Starts here and ends here. So that final vector I could call BA. All right, let's try again. Now we've got BA. Let's draw it down here. So whoa, that's not a straight line. BA, that's somewhat straight, plus AD, that's going to look down somewhere like that, plus DE comes back to this way. So I'm always putting my tail on the head of the previous one, and I'm going to make my resultant by looking at the original tail and going to the final head, and that is going to be this new vector here is my resultant. Straight line again, we're pretending. That straight line vector is BE. And that is the addition of vectors.